Good morning, sixth graders. It is Miss Scopes here to read you the next story in our reading unit. This story, Silent Noise by Jacqueline Adams, comes right after the Ace's phone. So you do want to pay attention and think about why did they write this story and what is its connection to the Ace's phone. If you're following along in your Journeys book or the electronic Journeys, you will find this on page 112 and it goes to page 114. Make sure you have your Google Slides open. There are 3 questions that you're going to have to answer that go along with this story. Dog owners are accustomed to seeing their pets prick their ears when everything seems silent. Like many animals, dogs hear sounds that are beyond human reach. Biologist Katie Payne listened to elephants communicate at a zoo in Portland, Oregon. Even when the elephants seemed to be silent, she felt the air throb. It reminded her of the throbbing from a pipe's organ's low, doleful tones. Okay, we're going to stop there. We've read 2 paragraphs now. Let's take a minute to think about this story, Silent Noise. Main idea. Who or what is this about? What was the kind of action that happened and why? And then let's look at question 1. It says, what does the word doleful mean in the following sentence? We're looking at this last sentence in the second paragraph. It reminds her of the throbbing from a pipe's organs, low, doleful tones. You'll see on the questions that I inserted an image of an organ for those of you that have not seen that instrument before. Oftentimes you'll find it in Catholic churches or in churches. So think about the meaning of doleful that you've learned earlier in the week. Okay. Remember, you may pause the video as you type in your answer. Let's continue the story. Payne began to wonder if elephants made noises not heard by humans. She recorded the elephants with devices that pick up sounds below the range of human hearing. She discovered a torrent of rumbling. There was a whole communication system down there that people hadn't known about, she said. This would help solve an elephant mystery that had puzzled biologists for years. Take a minute to look at this image and read the caption. Elephants pick up frequencies too low for humans to hear. How low can you go? Biologists have heard a wide range of elephant sounds, from mothers' gentle rumblings as they coax their calves along to urgent trumpeting that warned of danger. But how elephants kept track of each other in the wild remained a mystery. Elephants lived clustered in groups that stayed a couple miles apart but traveled in the same direction. When one group changed direction, other groups swiveled to follow. How did the elephants know what faraway groups were doing? The mystery was solved when Payne discovered that elephants communicate with infrasonic sound. Because low pitched transmissions travel farther, elephants can communicate over long distances. You might want to stop, think about what that section of the story, how low can you go, was about. Also, think about how it might connect to the heading, how low can you go? You'll also see there is a image here. Looks like it has labels. Eardrum, inner ear, middle ear. So it's kind of like a diagram of the inside of the ear of an elephant and the parts. Catch the wave. Sound energy travels in waves. When sound waves reach the outer ear, they are funneled inside, starting a chain reaction. The eardrum vibrates, moving tiny bones in the middle ear and passing the waves to the inner ear. The number of waves that travel each second is a sound's frequency, measured in hertz, Hz. That's the symbol for hertz. The human ear is tuned to hear frequencies between 20 and 20,000 hertz. You might want to stop and look at question 2. How do the sounds heard by a dog and an elephant differ from the sounds heard by a human? This is all about contrasting. We're not looking at similarities, we're looking at what is different. So take a minute to answer that question. Maybe pause the video, then we'll move on to the last page. Squeaks and chirps. Animals such as dogs, dolphins, and bats go to the opposite extreme. They pick up supersonic or ultrasonic sound frequencies. These sounds are above the range of human hearing. Even though bats can see, sight isn't enough for finding insects at night. Bats send out a clamor of supersonic chirps into what looks like a dark void. These high frequency waves bounce off insects and come back to tell the bat where the insects are. To humans, what seems like a quiet night is filled with silent noise. Let's take a look at this graph that the author included. It's titled Comparing Animal Hearing Frequencies. Looks like we're comparing the elephant, a human, a dog, a dolphin, and a bat. This graph could also help you with question 2. Down at the bottom, you will see in the graph, there's another label, and they're labeling the hertz frequencies: 20,000, 60,000, 100,000, 140. Take a minute, analyze that graph. Think about what it's telling you and how these different things that they're comparing, animals, differ. Then you want to take a look at this final picture with its caption, Greater Horseshoe Bat Chasing a Moth. That concludes the story, Silent Noise. Remember, you can always listen to this multiple times. There are 3 questions you have to answer. Hope you enjoyed.